I'm going to go through the process of removing the original equipment motor on the CGE and some of the things I've learned about the process. You will need an 11mm or 7/16 inch open end wrench to get the bolts in the back. The way this motor bracket is held on is by 2 bolts coming up through the bottom, and then the spacing for the worm gear that's inside the bracket to the worm wheel is controlled by shims between the motor bracket and the frame of this assembly. You'll want to, I've obviously taken declination off. It makes it a little bit easier, less cumbersome to, reduce down the weight, total weight. And it's very easy on this mount. It's just four bolts. So something to think about. I've removed the home switch and limit switch. I've removed the PEC PCB, and I've removed the wiring and such from the box, and that's how we got to this stage right here. So all we're left with is the motor bracket, the gears, the motor with the encoder, just like we're showing here. One thing I like to tell people is to make a mental note, or just kind of learn what the current backlash is on your mount, so you can kind of get a reference of where you started, and when you go and put the new motor assembly back on, where you landed. It'll help you decide if the original shimming is adequate, or if you need to do any additional shimming to get the backlash that you're trying to achieve. Obviously you have to have some backlash, or else gears won't move. So please don't try to tighten everything up so where everything is just locked together. The motors just will not operate. You'll just be making metal shavings. So if you just reach up and grab the worm wheel and rock it back and forth. Now this is before I've loosened anything. You'll feel and see just a little bit of clunk or back and forth on the worm wheel to the worm. You'll also see backlash in these gears. Like I said, you will have some backlash. So just kind of take a note, kind of feel it, go back and forth, and get an idea of where you started with on your backlash. This will help you as you go to put the new assembly on to get back to the original backlash, or change the backlash to whatever you want it to be. So now that we got it down to this amount of disassembly, the periodic error wheel is still on there. You can't really get to that until you pull out the bracket, but do be careful with that plastic wheel. I do have a 3D model that you can print to replace it, but it does get a bit fragile. So one of the first things I would recommend doing before taking this out is, let's take out this gear first. It's best to do this work while this unit is in here, just because it's already holding it for you. It's in its own vise. These are 1.5mm set screws that are in here, and they are Loctited. So do make sure you're using a good wrench. These I've been using for quite a while. They say they're made out of titanium, and I tend to believe them because they've lasted me at least 2 years, 3 years. They're good little wrenches. So 1.5 millimeters, and you'll want to make sure that's exactly what it is, and give it a twist. There's 2 set screws. I've had people with the CGE Pro kits strip these out, so make sure you use a good wrench. There's 2 of them. So those weren't too bad. So we got them loosened, and that's all we really need to do is while it's situated in here, let's go ahead and loosen those. Since it's already essentially clamped in, it'll make it a little bit easier. So now on to removing the 1/4 inch 20 bolts from the back. Just use your wrench, open end wrench or box wrench to get back in there. And I'll flip to the other side. So those are loosened. You can see the bracket is already essentially coming out. So these are 1/4 20 bolts, 1/4 of an inch by 20 threads per inch. Now, as we roll this back, you'll see the shims I was talking about a little earlier. These are the plastic shims. You'll want to make note of them. Take a picture, write it down. You can see this side is actually 2. There's a little piece of shim right there. So this is, I've seen different colors from different people that have taken their mount apart, and I think that's gray and brown. So those 2 shims were together, and this one is just a brown. You can see they're just stuck on there with grease. So now that we have this assembly out, we will make sure we note what it is, and you can now see in and see where our motor box is ready for our new motor bracket. All right, now that we got the bracket out of the mount, we need to remove the worm gear from this assembly. If you like, you can remove the motor. It's just those 3 screws, and then take this gear off. But the one key thing that I'll emphasize is you need to not hold this with your hand and then use the tool to unscrew it. Take your time and clamp it down. This is a wooden clamp I use for woodworking and such, and I'm clamping on the bracket. Don't clamp on the motor. I'm just doing this at this angle for a good camera shot so you guys can see things. But I'm not clamping on the motor, just for your information. I am clamping on the motor bracket. Now, there's this retaining ring in here that has some Loctite type of sealant. I haven't really identified what it is yet. It's kind of a non-hardening, semi-permanent kind of Loctite. With a special tool, you'll want to insert it so that you're catching those grooves. It's kind of like a spanner nut where it has 2 grooves that you put in. So you'll want to focus your energy in so that this doesn't pop out of the groove. You'll want to be pushing in more than anything. Let the clamp hold it. Get everything steady. Get a good purchase on it and loosen it up. Once you kind of get that first, and the thread or the Loctite sealant, it comes out pretty smoothly, but it's getting that initial breaking of that sealant that you'll want to focus on clamping it down so that you don't tear up these threads. So you can see what it looks like. It's kind of, like I said, a spanner nut where it's got 2 slots in it. And this is what captures the worm assembly inside of the bracket. So now that we have the capture nut out of the bracket, we can now remove the worm gear. And it may be a little bit stuck. You just apply some pressure on one end and it will pop and start coming out this direction. There's 2 bearings, as you'll see, as they start to come out. They will fit, everything can and does fit through this hole. If you leave the bearing behind, that's fine also. So this is your worm assembly. So this is what we're going to be transferring over to the new motor bracket. So you'll see one side is threaded for the PEC sensor and the other side has a flat for the worm, or for the gear that was on there, for the set screw. It has 2 bearings. You'll want to kind of give them a roll and see what they feel like. If they're not the most expensive bearings in the world, so they're going to have a little bit of chunkiness probably, if you're really particular. So they are easily replaceable if you do want to put different bearings in, but I'm sure what they put in there is just fine. But if you want to go with a higher quality bearing, you're more than welcome to. So that's that assembly. And that's all we'll need out of here. The main component that we got out is this worm gear. Now, installing the worm gear in the new bracket, there's an adjustment process. You can put your capture nut in too tight, and you can put it in too loose. So you need to kind of get a feel for this. Do this without the belt. You want the belt. You don't want the motor hooked up to the belt. You just want your capture nut in here. And what I do a lot of times is snug it down so that you know everything is kind of seated. It hit a hard stop. And I think right now the hard stop is this thread has reached its end, because look, we can still move this a little bit. Well, you might not be able to see it, but I can see it. So I do include spacer washers, and a lot of times it's one washer in there, and that will make up for any major differences in machining. This is where these ball and Allen wrenches don't work so well. Okay, so we seated it down, and you'll see the worm gear is crunchy. It's not turning well at all. We did take the slop out. It's in there solid. I can't move it. It's hard for me to record how much slop without putting a microphone right up on it or a camera right up on it, so you just have to trust me. So here's the process, is that's feeling better. I feel a little bit of crunchiness, which is okay. The crunchiness is the balls and the bearings and the dirt or whatever is in there. The bearings, the balls on the surfaces that are making that feeling. You'll have to keep you know, you can back it off and get back to slop, back and forth slop. I would recommend reducing that as much as you can without introducing friction. That's tight. That's got just maybe a thou or two of slop. So you're going to have to kind of go back and forth, and this is where using Loctite on this capture nut. Right now in my experiments, I've just been using some thread tape that you use, some plumber's thread tape, just to add some friction. Final solution, I'm not sure what it will be. It will probably be like a Loctite 222. It'll probably be like a Loctite 222 or something like that. Something with a relatively long curing time, so to say, that you could even use nail polish. Something very light. You don't want anything permanent. You just want, when you go and do this adjustment and you're happy with how freely it's spinning and the back and forth, that when you set this down and let that Loctite dry, it will set in place and you can go on with your work. I'm using the thread tape right now because I'm in kind of a development process where I don't want any Loctite right now, because I'm going to be taking this thing apart and putting it back together many times. You can do the same. Once you feel, you know, if you're at the point where you want to do some experimentation, just use something like a thread tape that will just put some friction on the nut so it won't just back out as you're using it. So this is feeling pretty good. I don't perceive, now, you know, if you want to get scientific, throw a dial test indicator on that and see what amount of movement there is. There's probably is a half a thou or something. I personally would just go with your gut. Go with your feel. Go with what you can see, hear, and feel. If you start getting into too fine of measurements, you're going to drive yourself nuts. So this feels very good. Yep. So that's a few tips and information on actually seating that retaining nut against the worm bearing assembly. We're going to now shim up right ascension. You can see I've got a payload on it. The payload is balanced because we're going to be taking the gear assembly in and out. When you take this gear out, this gear has nothing holding it. So whatever weight is on it, it will go in that direction. So we've got it balanced to a certain degree that it's under control. Now that we've got right ascension balanced, we have our worm gear assembly loosely in here, held just slightly in alignment with the 1/4 bolts in the back. We don't want them tight. We want to be able to pull this down to insert our shims and then push this back up to engage the right ascension assembly gear or worm wheel. So here's what we're going to do. We're going to take, I've been calling it the worm gear assistant. It's a spring-loaded 3D printed part. Do not have the wiring assembly block in there yet. You want this part down on that shelf. You want to have this kind of, well, maybe not on the shelf, but you want this so that it's pushing the bottom of the bracket up against. You want it to be seated very well on this shelf down here. You want this worm gear assembly bracket worm gear, how many words can I put together? Worm gear bracket. And you want that solidly down on the shelf. That's the important part here. So now that this is spring loaded, we can pull down on each side and insert shims. Right now, if I try to wiggle this gear or pulley, there's no backlash. The worm gear is right up against the worm wheel. So let's start with brown. Brown is 10/1000ths of an inch thick. So we're going to pull this down, insert the brown shim. Make sure that this worm gear bracket is down on the shelf and being pushed up against the face. And you can see we can wiggle this pulley back and forth now. We've created backlash between the two gears. Now, the reason why we are putting our payload up here is flex. There's going to be some amount of flex inside the bearing assembly of RA that this worm wheel is going to come down into the worm gear. So we are taking into consideration weight that we can adjust this backlash. Now if we want to, that is probably pretty good, but let's see. Let's just keep demonstrating different backlash. So we'll go down, that was 10/1000ths, we'll go down to blue, that's 5/1000ths, that's half. Insert that one, and we'll insert that one. We'll make sure our bracket is on the shelf. And you can see we have no backlash. So 5/1000ths is too tight. Now we can start combining shims. If we want to sneak up on, so that was 5. Let's add green, which is 3. So I cut my green one in half just to make it. So we've got 5 plus 3 is 8/1000ths. Okay. Nice and up there tight. Do we have backlash? Ooh, hard to say. I guess a little. I mean, it is sitting there moving. Now don't be too forceful on this. You can, shift the whole, because this isn't bolted in yet, you can shift the whole dang thing around. You're just looking for this little back and forth indicator. Make sure everything's tightened back up since I moved it. And I mean, I would say I would want more backlash than that. So that was a total of 8/1000ths. So you can see how we can combine these shims, get just about any number we want. Oops, let me pull the other green. So 10 is 4/1000ths. We'll go ahead and, so this is a total of 9. Now, how fine you want to do this is up to you. Personally, I would rather have more backlash than not enough. PhD guiding is going to guide out any backlash that you may have. So you can see that added about just a little bit more backlash there. So if I wanted to go with this, say we want to try this, what was it? Green, we went tan, this is 9/1000ths. Let's go ahead and we can cinch this. We can tighten down our 1/4 bolts. We're still pushing up. I'm gonna walk in front of the camera so I can see the other one. Okay. We can pull out our assistant, and we still got about the same amount, just a little bit. But you can see now, you can actually see how much, by tightening this assembly down and, you know, cinching those bolts, it's in place. There is no more moving of this bracket because it's in place. So this may be a backlash that you want to try. I would probably go a little bit more. I couldn't tell you how much. It's just kind of by feel and your experience. Now you can, if you want to be able to turn this a little bit easier, you can add a little weight over here and see. So you'll just have to try it and see what you think. So from here, we have a known amount of backlash, and we can try this out. Now, what you can also try is take your weight off. You'll see that you'll have even more backlash now. But you don't want to be going off no weight, because when you put your weight on, it's going to smash everything together and you're going to have motor stalling on the stepper motor. But you can see I can turn that with my thumb. So I know the motor can turn it. And of course it must be a little bit heavier one, and it's harder for me to turn it this way than it is this way, just the way it's balanced out. So that is shimming right ascension.